Alright, we've been studying work, power, and horsepower. Today we're going to talk through what it means to do work as we apply a force times a distance. Notice the units are in joules. We're going to be able to solve for power, where we determine work divided by time, and units for power are in watts. And we need to know that 1 horsepower equals 746 watts, because we're going to be converting our values into horsepower. So we're going to find out how much horsepower we have. We'll get into the energy, potential energy, and kinetic energy. Even though we've kind of dabbled with them, we'll come back and solve those and apply those a little bit later. So let's get into this one. So work is force times distance. Work is done when a force acts on an object and the object moves in the direction of the force. For example, when you walk, you do work. Your body applies a force to move your body, which is your weight, a distance. In doing work, you must use or exert energy. Work is being done in the picture to the right. The weightlifter is actually me. This weightlifter has to apply a force for a distance in order to lift the weight off the ground to the height in the picture. But the weightlifter does no work when holding it over his head. This is because there is a force necessary to hold it, but there's no distance in which the object is moved while holding it. So notice, in order to get this weight from the ground up here, this me has to lift it off the ground. So we have to apply a force for a distance. But notice, when we apply the idea of energy, by me lifting it, doing work up to this height, this object now has potential energy. And potential energy is going to be m times g times h, which you'll notice that when we lift it off the ground, we do work, which is mass times gravity times a distance. So notice they are related. Doing work in the stairwell. So this is what you've done. So let's look at what you've done, or will do, but you've already done this. You were asked to walk up the stairwell and calculate the work that you did. So let's use my weight and mass as an example. I weigh 194 pounds and I have a mass of 88 kilograms. I can convert my weight in pounds into mass by dividing 194 pounds by 2.2 pounds per kilogram. And this equals 88 kilograms. Since 1 kilogram weighs 2.2 pounds on Earth. So I simply took my weight in pounds and divided by 2.2 to get my mass. In order for me to walk up the stairwell, I have to move my weight, right? F of g equals mg, up to 4.2 meters to reach the top. In that process, I have done work. So work is force times distance, and I'm going to substitute for force, right? F of g, I'm going to substitute in mass times gravity. And this is simply just the substitution for mass and gravity in for force. So the work that I did was 88 kilograms times 10 meters per second squared times 4.2 meters. So I did 3,696 joules of work. I do the same amount of work whether I walk, jog, or run up the stairs. But I complete each of those tasks in different amounts of time. So I have different amounts of power for each of the activities, but I do the same amount of work. So when I calculate my power, the rate at which I do the work, power is work divided by time. So you can calculate power too, but you must know the time at which it took me, right, my 88 kilogram mass, to walk, to jog, and to run up the stairwell. So I walked up in 10 seconds, I jogged up in 6 seconds, and I ran up in 3.9 seconds. So to solve for power for walking, I take my total amount of work done, 3,696 joules divided by 10, and I get that I did 369.6 watts of power. In jogging, since I did it in less time, I take the work done divided by 6, and I find that I did 616 watts, or I have 616 watts of power when jogging. And lastly, the power when running is the work done divided by the time at which it took me. I ran up in 3.9 seconds, and I had 948 watts of power. Since I run faster than I walk and jog, I have more power doing the same amount of work in less time. But I do the same amount of work in each one of them. I do the same amount of work each time, whether I walk, I jog, or I run. So in order to convert this into horsepower, I need to know that 1 horsepower equals 746 watts. Horsepower is a means of comparing how much power something can put out. It's an old term that has stuck around. So it's still used today even though we don't use horses for tools anymore, only for dog food. So to solve for horsepower, I can divide my power, right, from the previous slide, to determine my horsepower for walking, jogging, and running. So my work done divided by time gives me my amount of power, And in order to solve for horsepower, I take my value of power here divided by 746 watts. And notice walking, I exerted 0.5 horsepower. And for my power jogging, I did this amount of work in this much time. I had this much power. This value of power, 616 watts, divided by 1 horsepower of 746 watts, shows me that I have 0.8 horsepower when jogging up the stairs. In running, I did this work in this amount of time, and I had this amount of power, 948 watts, divided by 746 watts, and I had 1.3 horsepower when running.